Okay, we are now going to talk about something called the counting principle. Okay, so when you're doing probability, a big part of probability is being able to count how many outcomes are in your sample space and how many outcomes are in the event. And they actually got several different rules that you can use, and probably the first rule that you would learn is this counting principle. And we're not going to necessarily use this very much in finding probabilities. What I want to do is I just want to expose you to this idea of having rules that can help you count outcomes, which would be very, very difficult to count otherwise, because there can be many, many outcomes. And if you ever took a probability class, then you would learn other rules as well. But this is kind of where they all start, with this basic rule. Sometimes it's called the fundamental counting principle. Okay, so the rule basically says this. So the counting principle basically says the number of ways of doing a sequence of actions equals the number, or equals the, I should say, the product of the number of ways to do each action. Okay, so this is actually what we did when we rolled 2 dice, because rolling 2 dice can be thought of as a sequence of 2 actions, and one action is rolling 1 dice, the other action is rolling the other dice. Okay, so you can think of that as a sequence of doing 2 actions. Okay, so rolling the first dice, there's 6 ways of doing it. Rolling the second dice, there's 6 ways of doing it. And so the number of ways of doing both actions is equal to 36 ways, 36 outcomes. Okay? So let me give you another example, because you can do more than 2 dice here. So these dice actually come, this is my Yahtzee game, and that's where I got these. And so in Yahtzee, you actually roll 5 dice, right? So let's see, I have all 5 of my dice here somewhere. Where did I put them? Oh, there they are. I actually have my Yahtzee cup there. So I actually have 5 dice. And so doing Yahtzee is like rolling 5 dice. Ooh, that's actually pretty good. I got 3 threes there. And so the question is, how many ways can you roll 5 dice, right? Well, according to the basic counting principle, rolling 5 dice is like a sequence of 5 actions. Rolling the first dice, the second dice, the third dice, and so on. So you're actually taking 6 and multiplying it by itself 6 times. Okay? And you can think of that as taking 6 and raising it to the 5th power. That's what exponents are for, to simplify your work. So 6 raised to the 5th power is 7,776 outcomes. Okay? So when you're playing Yahtzee, then there's 7,776 outcomes when you're playing Yahtzee. Okay? So let me give you another example here. These 12-sided dice actually come from this game called Math Dice. And what you're supposed to do is roll the dice like this, and then I think you're supposed to add these together and get a number, and then you're supposed to try to use the basic operations, addition, subtraction, multiplication, division exponents or something to try to get these to equal that. And the first person that can get a formula here to equal that would win that roll. That's kind of the idea behind this game. So what about this game where you roll these 5 dice here? Well, you can think of this as a sequence of 5 actions, where one action is rolling a 12-sided dice, another a 12-sided dice, and then a 6-sided dice, and a 6-sided dice, and a 6-sided dice. So I could do 12 times 12 times 6 times 6 times 6, and then I could find the total number of outcomes. Okay, so I'd get 12 times 12 times 6 times 6 times 6, and looks like there would be 31,104 outcomes. Okay, 31,104 outcomes. A lot of outcomes. So you can see that these numbers here can get very large very quickly, which is why these counting principles are so helpful, because they can count these large sets very, very quickly. Notice you could do a probability then if you wanted to. So I have 5 dice. Let's say I want to find out what's the probability of getting a 1 on every single dice. Okay, this is a pretty simple probability here, because there's only one way of getting a 1 on every single dice. Every dice would have to be a 1, kind of like getting snake eyes, but it's with 5 dice. So using this as the total number of outcomes, the probability of rolling 5 1s would equal 1 out of 7,776, right? So there's a very, very small chance that that could occur. Okay, so yes, extremely small. I'm not even going to try to write it down. Okay, and you can do something similar like 5, what's the probability of rolling a Yahtzee on one turn? And a Yahtzee is getting the same number on every single dice. And the number of Yahtzees is also an easy number to find, okay? So if you could use the counting principle to get like the top and bottom numbers, you could find a lot of probabilities that would be difficult to find otherwise. But there are these other counting rules as well that we're not going to talk about, okay? And basically in the homework assignment, I'm not going to really have you do very many probabilities using the counting principle, okay? I think I have one where you find the number, what's the probability of getting a Yahtzee. There might be one other one too, okay? But let me show you kind of some of the problems that I do have, okay? So this is a nice thing to use if you want to find the number of ways of doing a sequence of things. So let's say at a pizza company, they got 3 types of crust. Okay, let's say that there's 5 different sauces that you can get. They got a choice of 7 different meats. And let's say they got a choice of 10 different veggies. And let's say they have 4 different types of cheese that you could have on your pizza. Okay, so let's say our pizza, you would have 1 crust, 1 sauce. You would only put 1 meat and 1 vegetable on there, and then 1 cheese. So you could only get 1 meat, 1 veggie, 1 cheese, a sauce, and a crust. And then the thing is, what is the number of pizzas? Basically, if you select only 1 of each. Okay? So basically, this is like a sequence of 5 things, And there's 3 ways to choose the crust, 5 ways to choose the sauces, 7 ways to choose the meat, 10 ways to choose the veggies, 4 ways to choose the cheese. And then you could multiply these together. Okay? So 3 times 5 times 7 times 10 times 4. And you would get 4,200 different types of pizzas. Okay? So let me do another example where, let's say, a license plate contains we'll say 3 numbers, and this isn't necessarily true, followed by 4 letters. And the question is, you want to know how many license plates are there. Okay, well, there's 3 numbers, let's say, and then 4 letters. Okay, so for each number, you got 0 through 9. So there's really 10 ways to choose each number, and then 26 letters to choose from for each of these. And then you could multiply these together. And of course, there would be a multiplication there too. So you could say 10 to the 3rd times 26 to the 4th. Okay? 10 times 10 times 10, 26 times itself 4 times. And you could see there's a lot of license plates here. The number is 456,976,000 license plates. Okay? So a lot of license plates, right? So now let's do one more example here where I want to know how many license plates can you do if you cannot repeat a number or a letter, right? So you can only have the letters there once, the numbers there once. So there would be 10 numbers to start with. You could choose any of the 10 for the first one. But then once you've chosen a number, there's only 9 numbers for the second one, and then 8 numbers for the third one. Okay? And then there's 26 letters you could choose for the first one, and then 25, 24, and 23. Okay? And so if you can't repeat any of the digits or the letters on your license plate, then you would have 10 times 9 times 8 times 26 times 25 times 24 times 23. And in this case, there would be 258,336,000 license plates. Okay, so there's quite a few less license plates if you cannot repeat the digits. Okay, but there's still quite a few license plates there. But basically, any of these, you are using this fundamental counting rule to count these very, very big sets of objects. So in the last video, what I'm going to do is I'm going to kind of extend a few of these concepts just a little bit further, just to share with you some interesting things.